Regents Review number 28. When solving an inequality, you use the same inverse operations as when you solve an equation. So we're going to subtract x from both sides here, leaving us with 2 minus 5/9 x is greater than or equal to 4. And when I subtract 2 from both sides, we're left with negative 5/9 x is greater than or equal to 2. In order to clear this coefficient, we're going to multiply by the reciprocal, which is negative 9/5 on both sides. But when you multiply by a negative, you reverse the order of the inequality. So our final solution will not be a greater than or equal to sign, it will be a less than or equal to sign. And then you compute. So now, when we go to choose our response, we have to make sure we're paying close attention to that inequality symbol. Sometimes you reverse the order, and that only happens when you multiply or divide both sides by a negative. Question number 2. The highest possible grade for a book report is 100. The teacher deducts 10 points for each day the report is late. So that means on day 1, she'll subtract 10. On day 2, she'll subtract another 10. On day 3, she'll subtract another 10. So this is a constant change here, and that means it is linear, constantly decreasing by 10. Question 3. A plumber has a set fee for a house call and charges by the hour for repairs. So if you have a set fee and then you charge by the hour, this is the variable and this is the constant. The equation is modeled by C of t equals 125t plus 95. Which statement about this function are true? So this must be the set fee because it's the constant. And this must be the rate of change because it varies depending on the time the plumber works. So a house call fee costs $95. Yes. The plumber charges $125 per hour. Yes. The number of hours the job takes is represented by t, the time they work. That is true. So that makes 1, 2, and 3 all correct. Number 4. Which linear equation represents a line that passes through the point -3, -8? Well, there are 2 ways you can do this. You can do this by calculating the math yourself, or you can do this by using the TI-84. So if you're going to calculate the math yourself, you take each option choice and erase and replace the variables y and x with their appropriate substitutions. So y is -8 and x is -3. So is -8 equal to -6 minus 2? Yes. That's how you would do it using math. If you want to use the TI-84, you would use the y equals button. You would turn the calculator on, and in the y equals button you would type each of the options. So 2x minus 2. Whoops. You could look at the table by pressing second, graph, and then look for the value of -3. If it has a -8 as a y, then that's a match. I could try number 2 so you could see the difference. So that's 2x minus 8. When I look at that table, and I look at -3, the y value is different. Number 5. Graph the function, the absolute value of x plus 1 on the set of axes below. So I'm going to use my y equals button here. I'm going to type the absolute value bar signs. And there's a couple of ways you can do it. One is in the alpha F2 menu, right? So I can choose absolute value there. So when you're in the y equals button, you can type alpha window, alpha F2, to get the absolute value function feature. and the signs will pop up. Another way you can do it is in the math button by pressing over one time into the number column. You could do absolute value there. Another way is if you forget, you can always go to the catalog by pressing second 0, and you can go through this alphabetical list of all of the features the calculator has. Type x plus 1 here, get out of the absolute value bars, there's nothing else to type, and now we can look at the table of points. Now we know, by using our knowledge of absolute value graphs, that this should be a V shape. So you should graph as many points as you need to really show that whole V shape. So I'm going to start here at -5, 4. 1, 2, 3, 4, 5, 1, 2, 3, 4, and then -4, 3, -3, 2, -2, 1, -1, 0, 0, 1, 1, 2, 2, 3, 4. I'm going to keep going till I get all the way to the edge, and I can even arrow up and take a look at these other points, which I'm going to graph as well, until I get that perfect V shape. Question number 6. The ages of the last 16 United States presidents on their first inauguration day are shown in the table. Determine the interquartile range for this set of data. So I'm going to need a calculator for this part. I'm going to go into my Stat Edit button. If there's anything in there, I'm going to clear it out. Let's pretend I had some numbers in there. I can do that by going up to L1, pressing clear one time, and then arrowing down. So I'm going to type these numbers, 51, 54, 51, and 60, 62, 43, 55, 56, 61, 52, 69, 64, 46, 54, 47, and 70. Now, because these numbers are so random, I wouldn't know if my data values, my 5-number summary, are correct or not, so I'm going to go back and double check. 51, 54, 51, 60. Okay? 62, 43, 55, 56, 61, 52, 69, 64, 46, 54, 47, and 70. Excellent. They are correct. Now I press the Stat button again, but this time I arrow once to the right, and I choose number 1, var stats. Once I'm there, I can grab the numbers that I need, which are the Q1 and the Q3. So for us, we're going to write Q1 equals 51, Q3 equals 61.5, and I don't need to show how I got those numbers, but I do need to show how I got the interquartile range. And IQR is found by subtracting Q3 and Q1. So 61.5 minus 51, and I'm going to get 10.5, and that's what I put my box around. Number 7. How many of the equations listed below represent the line passing through the points 2, 3, and 4, -7? Now, I can do math, or I can use the TI-84. If I use the TI-84, it needs to be in y equals form. Only one of these is in y equals form. If I want to choose math, then I would erase and replace the x and y values like I shown there. So if I want to use the TI-84, I've got to do a lot of math here and rearranging. The first one means that the 5x would need to go to the other side, giving me -5x plus 13. This next one I would need to distribute and then subtract 7. That would give me y equals -5x plus 20 minus 7. Plus 20 minus 7 is also 13. The third one is already in y-intercept form. Ooh, look, these are all the same equation. And the final one would be plus 7, y equals 5x minus 20 plus 7. So this is the only one that's different. If this is the only equation that's different, then this is the only equation that could have points different than these three. So that means how many of these equations listed below represent the line passing through these points? So that means that either these three are all right or these three are all wrong. So let's use our TI-84 just to double check here. I'm going to go into my y equals button. I'm going to type negative 5x plus 13 in this one. And I'll type negative 5x minus 13 in the next one. And I will look at their tables. So the first one is 2, 3. And as we can see down here, the first sentence has a 2, 3, but the second sentence does not. When I look at the 4 value, the first sentence has a negative 7, and the second one does not. So the second one is not a fit. And that means the first one is, so that means that all three of these equations would go through those points. Number 8, the 24th term of this sequence is, let's see, negative 5, negative 11, negative 17, negative 23. So I need to find out if this is arithmetic or geometric. So I can use my calculator real quick. I always take the second term and subtract the first. So let's see, whoops. Negative 11 plus 5 is negative 6. Negative 17 minus negative 11 is negative 6. So it looks like we are decreasing 6 each time. Decreasing 6. So that means the common difference is negative 6. Now you can use your reference chart to look up the formula, but the arithmetic sequence is a sub 1 plus d times n minus 1. So the answer in the 24th position would be the answer in the first position. So for us, that's negative 5. The common difference, which is minus 6. And then the number we want, 24 minus 1. So I'm going to put that in my calculator here. Negative 5 subtract 6 parentheses 24 minus 1. And I get negative 143. Number 9. A company ships an average of 30,000 items each week. The approximate number of items shipped each minute is calculated using the which conversion? All right, the only way for a calculation to be complete is for items to be on the top and minutes to be on the bottom after we find things that can cancel out with each other. So in this one, items have nothing to cancel with. Week can't cancel because they're both on the bottom. Days can't cancel because they're both on the top. Hours can't cancel because they're both on the bottom, so that's a no. Week and week, day and day, hours and hours. This one has items and minutes, so this is a winner. Let's just double check everybody else. Days and days, hours and hours. Nope, these don't cancel. Days and days, week and week, hours and hours. Well, this one is minutes per item, which is not what we're looking for. So the answer is 2. Number 10, determine and state whether this sequence 1, 3, 9, 27 displays exponential behavior. Explain how you arrived at your decision. So as we can see here, this displays exponential behavior because it has a common ratio of 3. That's it. You could say it has a timesing pattern of 3, but this is the vocabulary that defends an exponential behavior. Common ratio of 3. Number 11. The formula of a trapezoid is given here. The height h of the trapezoid may be expressed as which? So that means solve for h in terms of capital A, B1, and B2. That's what that means. So when I look at my formula here, I'm going to times both sides by 2 over 1 first, giving me 2a equals b1 plus b2 times h. Now I'm going to divide both sides by h, giving me 2a over h equals b1 plus b2. Oh no, I didn't want to do that. How about if instead of dividing by h, I divide by this giant group of numbers? And now I get what I wanted, which is h by itself. b1 plus b2. There we go. Now that's better. Number 12. The solution to 2x squared equals 72 would be dividing by the coefficient first, giving us x squared equals 36, and then doing the inverse of squaring, which is square rooting, right? Now, square root is the smallest root, so we don't write the 2 there. And remember that a square root has both a positive and a negative answer. So that's why the answer is number 4. Because both positive 6 times positive 6 is 36, and negative 6 times negative 6 is 36. And that concludes Regents Review number 28.